what we're looking at here is the idea of absolute maximums and absolute minimums. Now, to determine an absolute minimum or an absolute maximum of a function, they have to specify a domain for that function over which to exist. And in doing that, that's when you can actually say it is a maximum or a minimum, because if we looked at this function across all real values, there's no actual maximum. We know it goes on to infinity because of how it looks, but because we specify this domain, it will have a defined maximum and it will have a defined minimum. Okay, so to give us an idea what this looks like, we're going to draw this x squared plus 2. So x squared plus 2 looks like that. But we're restricting the domain to negative 2 and 4. So it's going to look like this. We've got an endpoint here, we've got an endpoint here. Now, looking at that, we've got a minimum here at the turning point, and we've got a maximum. So the absolute maximum is the highest point it reaches. That's this thing here. That's the highest point it reaches. The absolute minimum is the lowest point. That's there. That's a turning point if we're dealing with the Pareto. But it may not be. We have to sketch it. I don't see any other way you can do this. Sketch it, and then you can actually see where these things happen. So now from there, we've got to just go about finding the absolute maximum, absolute minimum. We use calculus to do that. We use calculus to find this. So absolute minimum. So if we've got if f of x equals that, then f dashed x will equal 2x. We want to let f dashed x equal 0. So 2x equals 0. So that implies that x equals 0. At x equals 0, f of 0 equals 2. So we've got a minimum here at 0 and 2. That's our minimum. Our maximum happens at this value of 4, because that's our endpoint. So what we do is we find f of 4. That equals 4 squared plus 2, and we're at 18. So here we are at 0 and 2, and here we are at 4 and 18. So they'll tell us a domain. If they want us to find absolute maximum, absolute minimum, they give us the domain, they give us the function. Draw it. This looks like this. Restrict the domain, it looks like this. We can now see we've got a minimum at a turning point, a maximum at an endpoint. And using that information to find a minimum, to find a turning point, if it's at a turning point, we differentiate. If it's we find a maximum, we make it the endpoint. And we solve for our value that we've been given there.